Metric number CE190089, and I will present for activity 1 exercise 8. For activity 1, first I will construct the circuit based on figure 8.4 with its parameter. Here is the input voltage 240 volt, and here is the electrical part, which is 0.516, which is the km, the EMF constant, over 0.0281 S, which is LA. LA is the armature inductor, and plus 2.581, which is RA, which is the armature resistance. And here sum with mechanical part, 1 over 0.0221 S, which is 0.0221 is Jm. Jm is moment of inertia of the motor, plus 0.002953, which is the Bm. Bm is the frictional constant of motor. Then here is the tachometer constant. Tachometer constant 0.065 and torque constant 0.05. And here is the brake constant is 0. Then I will run the simulation. Here is the overview of the waveform. This is the waveform for input voltage. This is the waveform for electrical part. This is the waveform for mechanical part, and this is the waveform for tachometer voltage. To see the waveform clearly, I will click the scope. This is the waveform for input voltage. It is constant 240 volt. Then for waveform for motor torque, we can see that it will increase at 0. It will increase, and then at some point it will decrease and then become constant. For motor speed waveform, it will become increase, and then at some point it become constant. Then for tachometer voltage, same with the motor speed, it will become increase, and at some point it become constant. Next, I will construct another block diagram based on figure 8.5, and then this is the block diagram, and this is the parameter. I will set up the input speed to 400 rpm. Then I will run the simulation. You can see that the input voltage is 26 volt and the speed output 400.3, technometer output 26.02. Then I will repeat the same procedure for 800 rpm until 2600 rpm, and then I will record the input voltage and the tachometer voltage inside the table 8.2. That's all from me, thank you.
Now let's take a look at activity 2 number 1, which is we need to repeat step 4 in activity 1 and set the input speed to 2050 rem. To get the value of input voltage, we need to set the input speed to 2050 rem, and we get input voltage equal to 162.5 voltage. Now let's take a look at activity 2 number 2, which is we need to repeat step 1 in activity 1. we need to set the input voltage to the value obtained in step 1, activity 2, and then we need to state the brake to the parameter given, which is 0, 3, 6, 9, 12, 15, 18, and 21. After we set the brake scale, we can run the simulation and read the motor speed value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazri bin Zakaria, AE 190019. I will present about the activity 3. The activity 3 is closed loop speed control system. Construct the closed loop speed control system block diagram in MATLAB Simulink. So this is the circuit of the activity 3, which is this is the input voltage. This is the constant 0.05, tachometer constant 0.065, escape is constant 200, electrical part which is 0.516 over 0.0281 second plus 2.581. This motor torque. This mechanical part is 1 over 0.0221 second plus 0.002953. And lastly is the motor speed. The instruction is fix the input voltage to the value obtained in step 1 in activity 2 and set the brake to 0. So we run the circuit. So when we run the circuit, we can get the input voltage waveform, motor torque waveform, motor speed waveform, and tachometer voltage waveform. So for brake scale 0, we get the motor speed. So for brake scale 0, we get motor speed 3.660. For brake scale 3, we get 3.431. After we get the result, the motor speed, we can fill in the table 8.5. So the same goes for the brake scale 6, 9, 12, 15, 18, and 21. So for example, we choose brake scale 15. We run the circuit. And get the motor speed to 2516 RPM. So we fill the table. From what we know, when we increase the brake scale, so the motor speed will decrease. Alright, that's all from me. Thank you.